Hello students, today we are going to do the numericals on Newton's laws of motion. Now look at the question, it has been given. There are two blocks of masses 2.9 kg and 1.9 kg. So you can see the figure here. So there is one block of 2.9 kg, another block of 1.9 kg. Okay, and they are suspended from a rigid support S by two inextensible wire. You can see that this is one wire and this is another wire, each of length 1 meter. So the length of from here to here is 1 meter and from here to here is 1 meter. The upper wire has negligible mass, and it is mentioned that the upper wire has got a negligible, just read this line, okay, but and the lower wire has a uniform mass of 0.2 kg per meter. So it means what? We have to consider the weight of this wire, but the upper wire we have to neglect, right? So the whole system of blocks of wires and support have an upward acceleration of 0.2 meter per second square. Acceleration due to gravity is given 9.8 meter per second square. You have to find out the tension at the midpoint of the lower wire, okay, and find the tension at the midpoint of the upper wire. So you can very well see that if you get to see the figure, this is your figure. There are two blocks and they are being hung by two wires of 1 meter each. The masses of the blocks are 1.9 kg and 2.9 kg, and in this case we need to find out the tension at point A and B. A is the midpoint of the between the two blocks and B is here. So we need to find out first for the lower block. Let us assume we need to find, let us do with the solution. We need to find out for the tension at A. Tension at A is for the lower block, right? So in this case, the tension at the point A, if you look into the figure, tension at point A is what? This is equals to the weight. This is acting in our direction. So this is equals to T minus mg equals to mass into acceleration. So I'll write here TA is equals to T minus, rather I should write T minus mg is equals to mass into acceleration. So T suffix A is equals to mg plus A. Okay, so this is the formula we are getting, mg plus A, right? So yeah, what you need to find out here, m is equals to what? 1.9 kg, okay, plus the mass of the wire AD. Now if we want to find out the mass of the wire AD, so we have seen that it is given 0.2 kg per meter. So 1 meter it is 0.2 kg. So for half, so it will be half of this. So this is plus mass of AD, and this mass of AD we can very well write this is 1.9 plus half of 0.2. So that gives 2 kg, right? So tension at A is equals to 2, G is 9.8 plus acceleration due to gravity 0.2 given. If you compute, you are getting this as equals to 20 Newton. Okay, now next we need to find out the tension at B. Now if we want to find out the tension at B, this particular point, then this mass and this whole mass will be considered. We have to neglect this mass, right? So we will find out tension at B is equals to capital M and A plus G. We get the same formula, but M is what? M is equals to 2.9 plus 1.9 and plus the mass of this wire. So for 1 meter is 0.2. So we'll take the value plus 0.2. That gives the value as 5 kg. Okay. So tension at B, TB is equals to, tension at B is equals to 5 into A is 0.2 plus 9.8. So this becomes equals to 50 Newton. So this is how we need to solve such question. So if you get such question, please have the way of solving such question. We'll be doing more numericals based on this, and hopefully you will understand. But before doing with the numericals, more of the numericals, what is required for us to do or understand about the concurrent forces? Let us discuss about the concurrent forces. Okay, now concurrent forces, if we have, so we have the condition that if we have the forces applied on a body such that the lines of action meet at a point. So let us assume this is one x-axis, this is y-axis, this is F1 vector. So this becomes alpha 1 and this is F2 vector. From here to here becomes alpha 2, and this becomes F3 vector, and from here to here this is alpha 3. Okay, so we have got this figure, and concurrent forces we are discussing. So it simply means that if the force is applied on a body such that the lines of action meet at a point, so this force, the lines or actions are meeting at this particular point, then they are called the concurrent forces. So simply we have got, if we take R as the resultant, R is the resultant, so we can very well write R vector equals to F1 vector plus F2 vector plus F3 vector. Okay, so if you get to see the figure, then we can very well write for all Rx, so the component of Rx along the x-axis, so this is F1 cos alpha 1, and this is F2 cos alpha 2, and this is F3 cos alpha 3. So we can very well write F1 cos alpha 1 plus F2 cos alpha 2 plus F3 cos alpha 3, right? So we can write like this. Now in this case, what we find out, the y component, so it is F1 sin alpha 1 plus F2 sin alpha 2 plus F3 sin alpha 3, right? So the magnitude R can be written as very well, this is the R square x plus R square y, and we can very well get the angle as tan alpha is Ry by Rx. So this is what we have to do. So this is the concurrent forces. When we have got three forces and the line of action meet at one particular point, how we can resolve and get the value. So final answer is this. Hope you must have understood everything in this class. We will be doing more numericals based on the laws of motions, and you also give a try. Hopefully you will understand more if you practice more. Thank you for watching.